All right, hey again, everybody. I'm back from South Africa, maybe. We are talking about binomial experiments in 6.7. It's rather simple. It's when you have something that is being done a fixed number of trials in our quote-unquote binomial experiment. The outcomes are mutually exclusive. It's like we're tossing a coin. We have heads or tails. There's no overlap. And also the trials are independent. The fact that you toss a head does not affect the outcome of the next trial that you're going to run. And the probabilities are consistent. You're not tossing a coin, then rolling a die and doing something different. You're being consistent, okay? So that constitutes what's called a binomial experiment. So anytime we're dividing something into a 50-50 proposition, a true and false test where we're guessing, or heads or tails, or boys and girls, assuming that that's a 50-50 chance of happening. These are all things that are called binomial experiments in which the probability is 0.5 or 50%. All right? So for an example, we're saying something like, what's the probability that a family of 7 children will have 4 boys and 3 girls? So probability of 4 boys and 3 girls, we'll say, 4 boys and 3 girls out of 7. All right, what's the probability of that happening? Well, 3 boys and 4 girls. If we have 7 blanks, we could have girl, 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 and then boy, 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 and that's one pattern. But we could also mix up the boys and the girls in a lot of different ways. So we could have girl, boy, girl, boy, girl, boy, boy, or something like that. As long as there are 3 girls and 4 boys, we fit this criteria, and we're finding what's the probability of that. Well, our definition of probability is the number of ways we can get our favorable outcome over the total number of ways that can happen. And if you study these binomial events and you think about it simply, you can see the pattern. And the pattern winds up yielding Pascal's triangle. So for instance, if I have no coins, there's only one way I can have that no coin. If I have 1 coin, I could have 1 head and 1 tail. Right? There's one way to get 1 head. There's one way to get no heads. If I have 2 coins, there's one way that I could have 2 heads. There are 2 ways that I could have 1 head and 1 tail. And then there's one way that I could get no heads or 2 tails. So if you think about that, and if you keep this going, this is for no coins, 0 coins. This is for 1 coin. This is 2, and so on. I'm going to run out a little bit of space, but if I have 3 coins, right? If I toss 3 coins, I could have head, head, head. There's only one way that I could get 0 tails. There are 3 ways I could have 1 tail. It could be like that, or the tail could go there, or the tail could go there. There are in fact 3 ways that I could have 2 tails and only 1 head, because the 1 head could go there, or there, or there, and that makes 3. And then there's only one way that I could get no heads, and they'd all be tails, and so on. You might want to do this on your own and just keep this going, but think about if I had 4 coins, I could have only one way to get 4 heads, but then of course there are 4 ways to get 1 head. Turns out there are 6 ways that I can have 2 and 2, and you could list them all, and you'd get in fact 6 ways that you could have 2 heads and 2 tails, 4 ways to have just 1 head, and then there's only one way that I have no heads and all tails. So we get Pascal's triangle number. So going back to this, if I've got 7 people, it's like having 7 coins. If I'm looking for 3 heads and 4 tails, I go down here, just continue to row 7, or you guys can look at row 7 on your phone, taking the time just to write out Pascal's triangle down to row 7, because we're dealing with 7 kids, and we want to know the probability of 3 girls out of 7 kids. So I go down to row 7, and this is 0 girls. 1 girl can be found 7 ways in this list if I had 1 girl. 2 girls could be found 21 ways, and 3 girls right there could be found in 35 different ways. I have 35 ways I could sprinkle my G's, my 3 G's in there amongst the 7 spaces. Now, what's the total number? Well, we're down to this where I want to know what the total is across this whole row, because that's all of the different ways I can get my 7 children to have various genders, boys or girls. And we've done this before, and the total of any row is always the row number as the power, the exponent of 2. So my probability then for this question is just 35 over 2 to the 7th, because it's row 7, 7 girls, 7 children. And the short version of this is going to be 7C0, and this is 7C1, 7C2. So here we are, 3 girls is 7C3. So in the formula for this would be however many coins or children or true or false questions, and then CR that we're interested in over 2 to the n. All right? So there's our answer, and there's the formula that you want to jot down. And you can solve pretty much any problems like this. I'll do one more example from the book. Okay, we're back working problem number 11 on page 343. It's about 5 true or false questions on a quiz. And we're going to assume that we don't know what we're talking about, we're just guessing. So each one of these has a random chance of being guessed correctly, 50-50, because it's all about 50-50 chance, all right? So is a 5-question true or false quiz a binomial experiment? And the answer you have to get the answer, you have to ask yourself, is there an equally likely chance in each case? And we're assuming that we're guessing, so the answer is yes. Is there a finite number of trials? And the answer is yes. And are the questions mutually exclusive? And the answer is yes. Even though I have in my professional career seen a few of these, which I call a tulse or a fru, and there's no chance of answering with one of those and getting away with it. You can't try that, okay? So we've got a binomial experiment. It meets our 3 criteria. How many ways could I answer a 5-question quiz? Well, that's that 5th row, all of the different ways total up horizontally. That's going to be 2 to the 5th, which is 32 different ways, okay? You could try taking and just listing in 5 blanks all of the different patterns you can make with true and false, and you'll see that there are 32 ways. How many correct ways? Well, assuming there's only one correct answer for each question, there's only one way you could have a correct quiz. So the probability of getting your A plus would be, if you are purely guessing, 1 out of 32. All right? So once again, just like with the girls and out of a certain number of children question, it's all about how many particular ways are there to get that combination out of the total number. And that total numbers in a binomial experiment is always going to be the horizontal total for that row, which is going to be a power of 2. The number of ways you might get that, sometimes if they say what's the probability of getting 3 or more questions correct on a quiz like this, you have to find the probability of getting all 5, and then 4, and then 3, and then you add up each of those probabilities when they say something like 3 or more. You have to break it down into categories and then add those up together. All right, good luck on that 6-7 work.